Question 5 related to electric circuit assignment. So figure 9.1 shows a current potential difference graph, which is, or we can also say IV graph. For an IV graph, remember that what slope represent, the slope is reciprocal of the resistance. Means what happened? If the slope is increasing, it means the resistance will decrease. And opposite will happen. If a slope is decreasing, it means the resistance will increase. So we have two components, resistor and thermistor. For a resistor, it's a straight line. So what you can say about the resistance of a resistor? Is it increasing, decreasing, or remain constant? It's a straight line. So what we can say?
Constant.
Constant, because the slope is not changing. If a slope is not changing, it means the resistance will not change. So resistance will be constant for the resistor. But what about the thermistor? For a thermistor, when you check what happened to the slope for an IV graph,
resistance is decreasing.
So yeah, that's right. Because the slope is increasing. If a slope is increasing, it means its resistance will decrease, as they are inversely proportional. For an IV graph, if it is voltage current graph, then they will be directly proportional. The question is, calculate the resistance of a thermistor when the potential is 7. So how we can work out when the potential or voltage is 7? So you just have to use your graph. This is 7.07. You will draw a line from 7 and find how much current is there. On y-axis, the 10 boxes equals to 2. So each box is representing 0.2. So this will be 4.2, 4.4, and 4.6. So this will be 4.6. So we have the voltage and we have the current. We need the resistance. So how we can work out the resistance? Resistance is actually a ratio between voltage and current. So what will be R? R is V over I. Voltage is 7 and the current is 4.6. What's the answer for this? 7 divided by 4.6.
1.521.
So 1.521 or 1.52. We normally write the answer in 3 significant. So we can just write 1.5. Then you have to complete this table by looking at this graph. So you will use a screen annotation. By looking at the graph, complete the table. What happened to resistance of resistor and what happened to resistance of thermistor? In a table, just tick the boxes that indicate the effect on the resistance of a resistor and for thermistor. So resistance of a resistor, it's a straight line passing through origin. It means resistance is constant. But for thermistor, the slope is increasing. It means its resistance is decreasing. The next question, thermistor and resistors are connected in parallel to 7-volt supply. Calculate the current. If two components are in parallel, the total current is equal to sum of current in each branch. So we have a thermistor. This is a circuit symbol for thermistor, and this is a circuit symbol for resistor. Both of them are connected to a 7-volt supply. So there is a supply of 7 volts. So what we will do, we have to use this graph, and using this graph, we'll work out the current in each. So when the voltage was 7, because they are connected in parallel, the current was 4.6. If the current was 4.6 ampere and both have the same current, like this was having 4.6 ampere, this is also having 4.6 ampere. How much current entered from the supply, or what is the current from the supply?
9.2.
9.2, because the total current in a parallel circuit, the current from the supply is equal to sum of current in each branch. So it will be 4.6 plus 4.6. So that's equal to 9.2 ampere. So current, if they were in series, they will have the same. Like if what is the current in the thermistor, same current will be there across. So that's equal to 9.2 ampere. Then energy transferred from the supply in 5 minutes. So energy transfer, energy is equals to power into time, or we can say voltage into current into time. So we have an energy, the electrical energy can be in kilowatt hour or it can be in joules as well. So voltage, we have a 7 volt supply, the total current is 9.2 and it is used for 5 minutes, so it will be 5 multiplied by 60. What's the answer? How much energy, the total energy?
$19,320 joules.
So 19,320 and the unit of energy is joule.